Hey everybody, this is Andrew. Welcome back to the channel. In this video, I'm going to be discussing the reactions of alkyl halides, specifically elimination reactions. So we haven't covered it yet, but nucleophilic substitution and what I'm going to be covering in today's video, base-induced elimination reactions, are two of the most widely occurring and versatile reactions in organic chemistry, both in the lab and in biological pathways. So we're going to look at that closely today, specifically the E1 and E2 mechanisms. We're not going to be covering E1CB. That is a different mechanism that you will cover with a professor of your own, or I can cover in a later video. The E1 and E2 are the most important pathways. So recall that a carbon to halogen bond in an alkyl halide is extremely polar, and that the carbon atom is electron poor. Thus, alkyl halides are electrophiles, and much of their reactions or their chemistry involves polar reactions with nucleophiles and bases. So to begin, just a little background, elimination reactions are more complex than substitution reactions for several reasons. The first of which has to do with Zaitsev's rule, which I'll be covering in a separate video. That's enough content for an entire video in itself. So, as I stated previously, these elimination reactions can occur by a couple of mechanisms. The first one is the E1 reaction. This is where a carbon-halogen bond will break and give a carbocation intermediate, which is immediately followed by the base removal of a proton. So, let's take a look at this mechanism. So we see we have the alkyl halide. First, the leaving group, the halogen, is going to leaving us with a carbocation intermediate. That is where we have a positively charged carbon atom, and a base is going to enter the reaction mixture, and it's going to steal the hydrogen away, taking this bond and forming a pi bond in order to equal out that positive charge, leaving us with a more stable alkene product, whereby the base can then react with the negatively charged halogen in solution. So remember with the E1 reaction, when you're moving forward, 2 steps, and it's unimolecular transition state. You'll see the importance of this as we move into the E2 reaction, which occurs in one concerted step, and it has a bimolecular transition state. Let's take a look at this example of an E1 reaction. We see the first step, the leaving group leaves. This occurs prior to the interaction with the nucleophile. We are then left with a tertiary carbocation intermediate. So that's what the tertiary carbocation intermediate looks like. With that being said, a base is able to abstract a proton, and those electrons will then go to equal out the positive charge by forming an alkene. Now, recall, because that carbon atom lost an electron domain, it now only has 3 electron domains, making it sp2 or trigonal planar geometry. Recall from general chemistry that trigonal planar refers to the geometry of an atom that has 3 electron domains. So moving to the next reaction, the E2 reaction, which stands for elimination bimolecular, occurs when an alkyl halide is treated with a strong base such as hydroxide ion or an alkoxide ion. It's the most commonly occurring pathway for elimination. Take a look at this mechanism. We see that the carbon to hydrogen and the carbon to halogen bonds break simultaneously or concertedly, giving the alkene in a single step without intermediates. When we take a look at this example, we can see that not only is the E2 reaction an elimination reaction, but it's specifically an acid-base reaction in this example. This is because the OH, or the hydroxide ion, acts as the strong base, which grabs the proton, and the leaving group then departs. So we see this occurring in one concerted step. The hydroxide pulls the proton off. These electrons then go to form a pi bond, and the bromine leaves. The bromine in this case is the leaving group. So this leaves us with the alkene product, water, and the sodium bromide. Before we read that, let's take a look at the transition state. So there is no carbocation intermediate. This reaction occurs through a bimolecular transition state. via a concerted reaction mechanism. So all the bonds are materializing and dematerializing at one time. The substrate reacts with the proton at the same time that the leaving group is leaving. It's a beta elimination reaction, which means that the leaving group is attached to the carbon in the alpha position, and the hydrogen from the beta carbon is then removed. So we take a look at this. The hydroxide pulls off the hydrogen, which is on the beta carbon, and the alpha carbon is the one where the bromine is attached. I'll cover this more thoroughly in a separate video, but E2 reactions occur with periplanar geometry, which means that all four reacting atoms, the hydrogen, the two carbons, and the leaving group, lie in the exact same plane. It's kind of hard to show it with these drawings. I don't have any models on hand. However, do keep that in the back of your mind. Thank you for watching. I hope you found this helpful. As we move forward, I'm going to post a video on E2 and E1 reaction examples, just so you can get a better grasp on what kinds of reactions you might be seeing on exams, etc. Thank you for watching. I'll see you in the next video.